check it again. Okay. So I'm recording now, so be mindful of that. All right, so we can keep that group conversation afterwards. Till the end. Please remember to drop your name in the chat so as to register. I have 6 persons here, and I know that the class is about at least 15 persons, 13 persons should be at least in the group. So I'll be checking the numbers in the. All right. Is this the one? Yeah. Let's go to the section. So, all right. So this is a typical question that we looked at yesterday, right? Just to refresh some of you who haven't really digested, so to speak, as yet. So here you have a problem. It's really a 3D equilibrium problem. Where when you look at it, firstly, I wasn't able to get into it too much last night because of the limitation of the time, but we're gonna do that. All right. So as you look at this problem, it says here, since the particle D is in equilibrium, the net force on D, where it's right here, net force on D is FDA plus FDE, because look, we are concentrating on all these ropes, right? All of these. Not this one is not included, right? So that one is not included. Only thing we need to know about this one is the weight that comes down on this, right? And we know the weight. I think the weight was 20. If I recall this question, I think the weight was 20. I'll put it there because I'm not absolutely sure. So it's FDA. All of that is equal to 0. Or you could say that is the net effect of it because it's in equilibrium. Once forces are in equilibrium, then we say that the system, the net force is 0. So that is an understanding that has been established long ago. Once you see the word equilibrium, you can say the net force is equals to 0. So generally the particle with the net force being equal to 0, we can say that the Cartesian effect of the sum of forces in the x, I, meaning that that's in Cartesian form. So you have sum of the forces in I plus the sum of the forces in the j plus the sum of the forces in the y, k. So that is all in Cartesian form for this set. So that this is the same thing that we're writing back, but the only difference is that it is in Cartesian vector form for the net effect of the forces. And so these are the showing you the Cartesian, but they're all unit vector, all 0. And similarly, you could write for the scalar one. So one you have the vector one and one you have the scalar one. Right? Sorry about that. Let me silence this device. Okay. So the net effect, I'm gonna have to silence it because I'm not in any call now. So let me get this silence. Right. So the net effect is going to be equals to 0 for all of them. All right, so those are the scalar equation, if you recall from yesterday, right? All right, now the plan of action to solve this problem, yes, the weight is 20. So the plan of action to solve such a problem. One, can somebody remind me what was the first step? What do you remember about the first step? What's the first step you're gonna do? What's the first step? Number 1. What's it? Can somebody tell me? Nobody speaking?
Sir, would you write out all the sir, would you write out all the length of the ropes using the equilibrium formula basically?
Right. So the first thing is for you to write the position vector. So 1, you need to know the coordinates. 2, you need to write the so 1 is writing the position vectors. And you can find the after you find the position vector, you do the unit vectors. Right? So you say position vector is 1. So you do the position vector, right? And you and also the unit vector. Right? So those are some of the things that you would do first. Step 2, and you could find the modulus up here. The modulus. Who else wants to tell me what else you do? What number 2 you do now? What will be step 2? Step 2, people. Nobody talking to me? What step 2? Are you not all hearing me? I am not hearing anyone if anyone is
Yes, sir.
talking.
Sir, we're hearing. 1 second. Sir, for the
I don't think I'm hearing her.
oh,
It seems like she's chipping in. Can somebody else help if they can because she seems to be having a technical issue there. Can somebody else chip in? Matt Knight seems to be having a little issue there. Who else? Gordon, are you there, Gordon? Marco? Or March? Who else is gonna speak to me? Nobody else? Kyle? Daniels? Kayla Daniels? Or Donalds? And who else is there with me? What's
sir, you're going to no.
Sure, me there know about anyone's edition, so nobody go through that slider.
yeah, that's what okay. So all right. What you're saying, the next step to write the force for each line. So we're gonna write the force. So you're gonna write the force. Write the force for each line, and your force is gonna be in the form of the vector, because the vector will represent the scalar value of the force times the unit vector of the force. But remember that from last night? All right, so you write that. And once you write that now, so you're gonna write the force for each line. So you're gonna write the force for each line. After you write the force for each line, the next thing now you're going to you're gonna write again the force in each of the three in the x, y, and the z. You're gonna write the equation that represent the x and y, the sum of the force in each line, right? And then after that, you're going to solve. So you solve down here. All right, so let's go and look at how it's done here. It's right here now, just asking you. So look, what we did here, just recapping, we, on the system, because this is now the free body diagram, we went ahead and we identified the coordinates of A, the coordinates of B, and if you clearly can see that A, let's look at A. So A is 4.5 for I. Why? Where is 0? So the origin is right here. X for in the x direction, if you're looking for A, let's look for A. So A would be coming right across here, 4.5 up to here. See there? Along the x. Right? So that is why we get that value. What is a y? There is no y component, because y, the negative will be going, the negative y will be going that way. If you look, it has no component because it's directly on top of the x axis. Right? So in reference to the 0 point, y is 0. But what is the z direction now? In the z direction, it is 3 going up. So that's how we got 3. Right? All right. What about b? For b now, your x component, you're treading along here, and you come right to this point. If you look over here, you can see that it corresponds to 1.5. So, right, so 1.5 is x, and you look good for B. it has no look good. If it is here, right here, it means it has no y component and it has no z component because it's directly on top of x-axis. So that is 0, and both y and z is 0. Let's go to 3 now. C, pardon me. So C, what's the x component? It has no x component. It's lying directly on top of the y axis. This has no x component, but it has a y and a z component. So in terms of the y, you look across here, right, and you map it going up to here, you can see that it is 2.5. So it's 2.5 going in the y direction. Who don't see that it is 2.5? So along here is 2.5, right? Going across there, 2.5. Then now,
Sir, I see the measurements, but I just don't.
are you seeing that I am writing on the screen? Are you seeing any writing?
Yes,
Are you
sir.
able
Yes.
You so it's right along here. You see it? That distance there. You see that now? Are you seeing it? Can somebody confirm you seen that, right? So right here is 2.5.
Yes,
Sir,
And then, yes?
sir, I'm seeing the actual.
What are you seeing?
Sir, I'm seeing the measurement, but I'm saying. Sir, I'm seeing the broken line and I'm seeing the red dot as the pointer. I'm seeing the diagram. But sir, I'm just not understanding what you're talking about when you say it's not in the X plane. Or sir, like I see clearly with B that it's going directly to the X or whatnot.
All right, so look.
So there's no
Coming across
YRC, but
here.
that one.
Look, it's coming. This is your origin. This is origin. This is your x-axis. This is your y. You need to get that frame as the first thing you try to identify first. So this is your y, and this is now your z, right? And then now you're gonna map each point in relation to the origin of those. So I'm gonna pick up a writer now. So you're not gonna see that. I'm gonna write again now. So let's roll back. It has gone forward. So right now, what we're saying here, so for it to get C is over here. You see up right here, so everybody see where C is? So we're looking at C, right? And for C, you want the components for C. So if you look, C has no X component. It is directly above the Y axis. So if you map it back, it goes nowhere into the X direction. So the X direction over here now, it goes nowhere there. And this is Y. So it's only in the Y and the Z. So in the X, that's why we have to put it as 0. For the Y, it's this distance right here. See there? Can you see that above the y-axis? And for the z, it is this distance right here. See there? That distance right there. All right. So those are the distance mapping the points. So this is 3. So one is 2.5 for y and x and z is 3. The next one is d. D now, if you look in relation to the origin, right? You look for D, what is the x direction? In order to this here, you look in the x direction, what's the distance? And you see clearly, this is the x direction, right? This line here represents the x direction, and it is 1.5 from the origin. So if you were to map D to the origin, it is 1.5, right? And so it's right here, 1.5. What about y now? Why you have to look in this direction? So you see there, see into this direction right there, you look on that distance is 1.5, right? And okay, and then now in terms of the z-axis, it hasn't gone into the z-axis, it's right in the, it's lined up with the origin, is right for all 3 axes. So it's only in the xy plane. These only in the xy plane. Right? And this xy plane, so you have x coming along that way, right? And you have y coming along this way. I hope you can see that. And so it is 0 in the z direction. So let's look at quickly what was done. So the next move here was you write the position vector for dA going from D to A, right? So so dA is 3i minus, and how did we get that? We use relative vector, remember? To get dA, position vector dA. So dA r dA is equals to A minus D. But remember that, right? And that's how you got the points. You remember, and you write out all A points. So A would have A, what was A again? A was 4, so it's right in front of me, 4.503, and you minus. Remember that this methodology, and D would have been 1.5, 1.50, and then you subtract. So when you subtract, you will get, for the x's you get 3, and for the y you get minus 1.5, and for the z you get 3. So you see there, see all 3 values here. And if you find the modulus of that, and everybody remember how we find the modulus? The modulus of the vector is you use Pythagoras theorem, you square each quantity, and you take the root. And when you square each quantity and take the root, it is 4.5. And when you have 4.5, you are able now to find your unit vector, because your unit vector is going to be 3i minus 1.5j plus 3k divided by, and you divide each quantity by 4.5. And there you get 0.667i, then you get 0.33j, then you get 0.667k. So you get all of these values when you divide by the 4.5. And that's your unit vector. And what the unit vector does, the unit vector will map going from D to A. So you're going, so that is showing you that is your unit vector going from D to A in that direction. So right along where you see this arrow going, that's the direction. So it's showing you the direction of that position vector. All right. And so that one. Let's move on. All right. Next now, the same thing will apply to position vector DB. So DB is right down here. B, remember B is right at this point down here. Right? And come again, what's happening here? Right. So what you do here, the same thing, same rule apply. RDB is equals to B minus D. Remember, simple, you know, relative vectors. So you get position point B, and B was 1.500, right? If you do it this way, you can't make mistake, you know. And then D, you put D 1.5, 1.5. When you get comfortable with writing them now, you can just look at it and write it and know what it is. So the first one is 0, because 1.5 from 1.5 is 0. So the next one is going to be 1.5, and then the other value is 0, right? The square of 1.5 is going to be the root of the square of 1.5. You work out that, you take the root of it, you're going to get back 1.5. So you get, so the modulus of it in this instant is 1.5. You go again, and you find the unit vector. And how did you find the unit vector? You do this very same thing. You take the position vector. So in order to get unit vector, you take the position vector 0, I plus minus 1.5 j plus 0 k, and you divide it by each quantity by 1.5. It will give you the unit vector, which is 0 minus 1 plus 0, right? And that's typical of unit vector. Once you have a position vector and it's only going in one direction, it's typically the axis that it is going in that direction. That axis coordinate for this unit vector is typically 1, right? in this case, it is -1, right? It's -1, so it's 0, -1. So in the x direction, it's saying that it is 0. In the y direction, it is -1. And hold on, what is going on here? Where are we? Yes, dB, dB. That is going from D to B. Okay, going from D to B. Yeah, so it's to say it is -1 going that direction, and then you have 0 in the Z. So that's the unit vector for that point. And then for C, let's move on to C now. Pretty much the same thing. So let's reviewing before we go ahead. So you have RDC, you do the first same thing. So you go RDC, so you're going the relative vector, C minus D. So you look for all the coordinates of C, which is 0, 2.5, 3, and you write your column. Minus D, and D is 1.5, 1.5, 0. And it equals to minus 1.5 from 0, you're gonna get minus 1.5. Here you go. And then you have 2.5, 1.5 from 2.5, you're going to get 1. So you see it, you get 1 there. And 0 from 3 is 3. So you get, for your position vector, minus 1.5 plus 1j plus 3k. The modulus of that is 3.5. So you take the modulus of that, all the quantity square, and you take the root. Similarly, you take the 3.5 and you divide each quantity in the position vector, and you'll get this unit vector over here. All right, so that is how you do it. The next stage, right, you go again, and you start to write your force for each line. So in this case, your force, hold on, what is this writer coming up here? I don't want to use this writer here. Right, okay. So in this case, go back. In this case here, you will have dA is going to be the scalar value for dA, which you don't know. These are what you need to find, times its unit vector, which is going to, so you put your unit vector in and you multiply dA. So now remember, you'd have found your unit vector, you know, and you multiply your FDA by a unit vector for each line. And this is how we get them. Once we reach here, you can clearly see that you can map out your quantity for your X, all of the blue. The quantity for your Y is all of the green, right? And the quantity for your Z is all of the purple. So this would be for the sum of the forces in the X, 0. For the green, sum of the forces in the Y equals 0. And for this one, the sum of the forces in the Z equals 0. And so you have 3 equations, right? The last one that we have down the bottom here, it is just telling you that it is the force in the, this is the force in the Z direction. Why so? Because remember the weight, the weight coming down in the Z. So it is -20. So -20 must give you, so it's -20, and in the earlier axis it's 0, 0. So that is the force in that direction, right? However, this one here must also goes with that axis because it is purple. So you only have 3 equations in effect, all right? But that one down there was put to explain to you why do you include the 20, right? So the vector, the position of BC, right, give you that position there. All right. So let's tread on. All right. So from this now, this banner is in my way. Let me get it out. All right. So from this now, you are able now to see that you have written 3 equations. And once we reach here, it's just a matter of using substitution to solve them. So we are now going to look back at our problem. All right, so everybody could see that how it's solved. And the methodology for solving it is right around here. So it's typed around here. I try my best and type it and put it around here. So you can see all we did, we made this we made FAD from the first equation around here. Right? Hold on a second. I can move this banner. Banner is in my way. Can I get it to go somewhere else? It's in my way. All right. So what you do here for this equation here, you simple. Everybody can see for the very first equation. All I've done here is make we transpose for FDA, and so you get equation 4 from the first equation. And after you've done that, you take FDA and you put it in the third equation. See it here? So you take this now and you put it in your third equation, which is this guy up here, which is right here. Right, so you see the 20, you can carry 20 over, you drop it in anywhere you see FD, you put 0.6432. So see it right here, and then you'd have had another FDA, and you sum them right there, and you just do the division. So because you'd get, when you sum the two of them, you get 1.286. You take it and divide the 20, and you get 15.55 pounds. And then now you proceed from that. Once you get this, you're able to put it back into equation 4. Put this in equation 4, and you'll get 10 pounds. After you have done that, you put the two values now in your second equation, which is a green one for the y, and you simply get FDA. You transpose or FDA out of that, because that would have been the only unknown you need to find, and you get the value there as well, 1.3. All right, so let us move now to our problem of the day.
Oh, sir. I have a question, sir. You can go back to the original equation I derived from the diagram.
Hold on, let me
That's
go
slide
back.
23.
This one?
I don't want to know.
Here?
Yes.
Right.
Yes, sir. So after this point, sir, where do you take the x components at each of the equation?
Yes, so we formulate. So now these are essentially your equations that you're looking for. This is for the x, all of that. So the sum of the forces in the x, 0. So that's your equation for your x. And for your y, you take the green, everything green. So you're labor right there, right? And you say sum of f of y equals 0. So you must remember that. Remember that when you said I said that you're a labor right there. That's a joke. All right. And then the sum of your f of z equals 0. All right, so you're going labor again. So here now you're going purple. You're mourning. So you mourn right along, and you notice that the 20 is incorporated in it because the 20 gone down. You never necessarily had to write the fourth equation, you know. All you know, once it's going down here, it must be a part of the z equation. So you could put it in as minus 20 equals 0. You could put it in and equate it to 0 just the same. Because, so if you put it in as minus 20 equals 0, you won't be wrong. Has that answer your question, sir?
Yes, sir.
All right, good. We're going to jump on now, and we're going to run to our tutorial sheet. So, all right, I'll stop share this one. I'll close that one out, and I'll go back to our original page. If you're not seeing, please tell me. I shared my desktop, so you should be able to see everything. All right, so the first part, the first part of the question, right, it says here, it says, as shown in the figure 1, 20-pound crate is suspended from 3 ropes. So we are not concerning with ourselves with this rope down here. This one right here. We are not concerning with that. Right? We are concerning with the rope AC and the rope AB, right? And we're also concerned with the which other rope now? AD. So AD is sitting directly over the Y. Can everybody see that? Picture it now. AD is just if this is your y-axis and this, sorry, if this is your y and x-axis, it is AD is like that over it, right? So it's AD and it is 4. So in other words, in the y direction, in that case, it would have been 4. But you know that this is, in other words, this is like Z. This is ZY. So I wasn't really wrong in writing it that way. Let me just repeat that. So let me just write it the correct way. Yeah, so this is Y and this is Z. So it's in the ZX plane alone. So this is D. So this part is coming down. This is 4. So does that mean in the Z direction is 4? And in the Y direction is what? 3. Can you see that? All right. So let's go ahead. What will be the first thing we need to do here now? And I want you to work with me now. Please open your mics and work with me. So the first point we need to write A. We need to identify the coordinate of A, coordinate of B, and the coordinate of C, and the coordinate of D. Right? So you're going to tell me them now, please. So the first thing you need to do. What is A? What is the coordinate of A? What is the x value for A? In the x direction, what is its value? Look,
0.
this is the origin. Everybody say that is the origin, so therefore this is 0i. And then what is the y now?
6.
It is 6j. Yeah. How much is it in the z direction?
0.
0, sir.
Ah, beautiful. All right. All right. Next one is B. Come again with me now for B. B now. All right. So look.
-3, sir.
All right. -3 because look. If we all don't see it, see the direction there, but it is going in the negative direction. So you have to put it as -3. All right. All right. What about in the y direction? Is it fair to say that it is 0?
0. Yes, sir. 0.
Because there's no way it go into the it's still on, it's over the x-axis. It's mirroring the x-axis. So if I was to draw this one, I would draw this. And listen to me. I have my reasons for doing this, so watch out. So you notice, but it's in the negative x. And therefore it is what? 3 in the negative. Right? And in the y, how much is it in the y? It is 2. Everybody see that?
Yes, sir.
So it's, and this is positive 2 in the y because this is positive z, while this is positive x. So this is negative x. But you see that? So that direction is positive, and then you have the origin there. All right. Next one now. So this is 2k. C now. All right. Somebody tell me the value for C. So C is this. It is Z and it is X.
Negative,
This is
2i.
Positive
2i.
Right. So in relation to the origin, C is right here. So this is the origin. This is negative. This is positive X. This is negative X. And it is telling me that it is going up 3, and along here it is 2. So therefore I must put 2i plus 0j. That has no component in the j direction. Plus it is 3. Watch that conversation in the background, please. Thanks. All right. Next one for D. For D, it is what now? What is X or D?
0.
0i. And what is J?
9.
Everybody see what it is? 9, because it is 3 here.
3, sir.
And then it's 6 there. So it must be 9.
Oh, yeah.
9.
Yeah.
Oh.
And it is 0. And it's 0k. But
From origin.
yes. Somebody asked a question.
So it's
Oh,
zero
sir,
K.
continue. You continue, sir.
It is 0. Is it 0, K?
No, so not 4.
No, sir, 4.
Oh, all right, cool. All right. So it is 4, and it is positive because it's going up. Right. Okay. All right. Nice. So now that we are done that, it asks us. So the question asks us some particular thing, and it asks us some things that So it says here specifically. It says determine the position vector of the 3 ropes. And it says taking the positive vector pointing, taking the position vector as pointing towards A. So we're gonna find them going towards A. So let's write them going towards A now. Let's go. So it needs CA. CA is going to be equals to A minus C. So you if you're doing it a long way, and I
Yeah,
tell you, practice it
-2.
this way first, and then when you get comfortable with it, you are able to just write it as you go.
Sir,
Right?
2, sir, 2, -6, and
So let
3.
me go and take it up. So A is 0, 6, 0, and then C is 2, 0, 3. That's what you're saying? And then so it is going to be minus 2
6.
I plus 6 J, and it's going to be what? Minus 3K. Do you agree with that?
Yes, sir.
Yes, sir.
All right. Next one. Which other one they say they want? They want BA. So you're going from B to A, and the relative vector say that is A. That's B. So, and for this one, you simply put it again, A, and you put B. So A is still again 0, 6, 0, and B is minus 3, 0, 2. And this gives what now? So you get from this,
Sure.
3 from 3, you get what? Plus 3, right? Everybody see that because you have the minus here, so minus and minus give you a plus, all right? And then the other one now is 0 from 6, so you get 6J, 2 minus 2 from
And
0,
minus 2K.
minus 2K, all right? And the proper thing would be to write FT beside them, eh? That they're all, that is the proper notification. Next one is last one here we need to write is DA. The DA is be equals to A minus D. A again 0, 6, 0, and then you have D now. D was 0, 9, 4. Let me see if I can come up a little bit. Yeah. So here we have, it's going to be 0, I,
0, minus 3,
minus 3, right? And then you have what? Minus 4,
minus 4.
right? That is J, this is K. All right, so those are, right? So that is what it wanted from you, the position vector. After you have the position vector, it says, determine the unit vector along all 4 ropes pointing away from A. So now they want all of them, but they want the reverse order. So you need the position vector, but the position vector must be pointing to where? Away from A. So we just found them going to A. And away from A, so that means you're going to reverse each position vector order. So it means that the first one we found was CA. So CA is equals to minus of AB, AC, so, AC, right? And similarly, BA is equal to minus times sorry, I think I write that wrong. Let me
Yeah,
write
necessary.
that written wrong. I'm gonna rewrite it. So yeah, so you want
AC.
AC. So AC is a minus times CA, And similar, you wanted AB, which is a minus of BA. And the next one, you want AD, which is minus times DA. All right. So what it means is that the components, let me get that a little. So what it means is that each component will be each position will be multiplied by a minus. So for D, CA was minus 2I plus 6J minus 3K. All right. So that now gives you what? 2I minus 6J plus 3K, and we have to make sure we get them right. If you don't get these right, you're going to get the whole problem wrong. And the next one is minus times 3I minus plus 6J minus 2K. So this gives you minus 3I minus 6J plus 2K. Right, so that's the position vector we want to work with. And then for this one, it's minus, what's this DA now? DA is 0I minus 3J minus 4K. And you multiply 2 by the minus, you get what? 0I plus 3J plus 4K. All right. So those are the two position vector we need to be working with. So they say they want the what now? The unit, we're not finishing now. They say they want the unit vector. So we need to find the unit vector for each. So the unit vector of says UAC is going to be the position vector divided by the modulus. So the position vector is 2I minus 6J plus 3K. And then you Pythagoras. So it is 2 square plus minus 6 square plus 3 square. So the 3 has a negative. I don't need it to put a bracket. All right. So you can tell me the modulus. You can find the unit vector of that. What's the modulus of that? Work out the modulus of that for me, please. 2I. This is plus 2 minus 6J plus 3K. What's the value for that? All right. And then the next one would be UAB is equals to minus 3I minus 6J plus 2K. And you find the modulus of it. So you take the root, you square each quantity, right? Plus, come on, writer. Come again. Then you go, I've lost my writer. Give me a second. All right, send me back. So it's plus minus 6 square plus 2 square. Right? Please give me the modulus of those. And the next one would have been UAD is equals to 0I plus 3J plus 4K. All up on the root of, come on, writer. Root of, hold on. All right. There's a root upon 0 square plus 3 square plus 4 square. So that one look like is 5. So it's 0I plus 3J plus 4K upon 5. Right. And so that will give you a 0. 3 upon 5 will give you what? Look like, so it's 3I plus 0.6 J plus 0.8K equals 0 for that one. What's this one up here now? Anybody prepare? So it is minus 3I minus 6J plus 2K. What's the square of 3 square plus 6 square plus 2 square? How much is it? Is that 7? Because it's
Yes, sir.
49, so it's 7. And then what's the unit vector? And what's the next one up top here? 2 square is 4 plus 36
Oh, I want to give it.
How much is that? How much is that?
So your screen will freeze.
What is freezing?
Your screen, sir.
Oh, what it means that you're not seeing it?
It just taking a minute for your what you're writing to come up.
You see it now?
Yes, sir.
All right. What is the modulus value for AC? What the modulus you get for AC?
That's seven. It's in the same seven.
Same 7.
Yeah.
Okay, right. And therefore, from that now we can write the unit vector. What's the unit vector you get? 2 divided by 7. So you get this one is 0.5
0.285 or two. Sir, how
7.
much places do you want? Three?
Yeah, that's all right. Up to 7. What's the next one now? 6 divided by 7, you get plus 0.857 J. What's the last one now? That's 3 divided by 7. You get plus 0.4285. Right? So that's the unit vector. And that's K. What's the next one down here now? The AB for AB. AB was what again? So the first one, we know the first one is minus though. Let me see if I get that right. So it is 0.4285 high. Then what is it J now? There's negative, which is going to be 0.857 J. Right? Let me look if those values are correct because
Sir.
I'm not hearing you guys at all, you know. You sure those
Sir,
values?
the one for AC,
Mm-hmm.
it's supposed to be minus 0.857.
0. Hold on. AC. Let me check AC.
So it must have -6.
0.857 minus 2. This one here you're talking the first one right here.
Yes, sir.
Yeah, what about it?
So isn't it supposed to be? Oh,
It's point
well,
two
no, sir. It's not
AC
supposed to get the
high minus 0.57 J, which is what I have, plus 0.42 85 or 9. We can round them off a little bit and work with 3 sig figs.
Also,
Because I
man,
have
talk about the
4.
for the first one is
About the
minus six
AC.
J.
Is for the first what?
Yes, so you have positive 0.857. Supposed to be negative.
Yeah. Let me check the signs, them. Oh, thank you.
Yeah.
So this is positive. So hold on. Let me see what I have. This is I see the minus. So this is supposed to be a minus value right here. That one? Right there, so right? The minus is right
Your
there.
screen
Yes, sir.
freeze again, sir.
Huh?
Yeah, screen freeze by my side, but yeah, it's just that was just the only one.
Yeah, right. Very, very important. All right. And AD, let me check AD value. AD look like I should have a minus there too. Let me just check AD values. AD value, we're supposed to have a minus with AD values. Let me see, where am I? Where my equation? Oh, hold on. AD, hold on, let me check AD. AD is telling me that I should have some minus signs for my unit vectors. And right now I'm seeing I have plus signs. What went on with AD up here? Wasn't it A minus D? Did I have some negative that I didn't? These were negative. So why am I seeing that? So that DA. I'm looking to see.
The AD's was 0.
AD is
+3 and +4.
AD, hold on. Yeah.
No -9.
Yeah. Okay. I'm checking the values them, just checking the values them to make sure that they are okay. Because you see, if I get negative when it's supposed to be positive, then you know it throw me off. But so far, all right, that looks good. It looks good. All right. All of those are correct so far. You see, you have to concentrate. Enough concentration too. So AC is all positive. Say this one, and then this other one now is we miss a value for this one, like it gone. The last one is supposed to be what? Plus something here. What's the K value? Or we never finish write the K value. What is the K value? 2 divided by 7. How much was that value? 2 divided by 7, how much
Oh,
you get?
that's
That is for
0.2857.
yeah,
0.285 or 0.286
6.
since I use 3. Yeah.
Yeah, right. So there, so we have 2 minus. Let me put the minus here so the minus jump off. So that is minus plus. All right. So you have to make sure. So all right. So now we can write our equations. So the first equation we need to, what did it say? It's just ask us to find that part is also the unit vectors away from A. So the next one now, so all those unit vectors are away from A. So now we can write the force. C now says determine the magnitude of the tension of all cables. So now we're gonna write the forces. So the force F, take each line, FAC is equals to the modulus, the scalar value times the unit vector going in AC direction. So let's write that one. Let me see if I can get a different color writer, which might make a little bit of contrast. All right. So for this one is FAC, and you put the unit vector there. Let's see if we have it right here now. So it's 0.2857, or we're gonna call it 6. We're gonna use 3, 6. Make life a little bit easier to manipulate. All right. I minus, 857J plus 0.4285K. All right. After you have done that, so that is 1. Right? So typically it is 0.286 86 FAC, right? So you can drop off the item and just write these components here. You can put I, and then when you're writing the equation, you drop them off. So then now this was minus 0.857 J times, put the J behind, then you put the force here and put the J behind, plus 0.4285 FAC, and put the K unit vector. So that now you have one expression. The next one now is F AB, which is the vector, the Cartesian vector is a scalar value, FAB times the unit vector of AB. So this is a unit vector, and you write the unit vector and multiply it out now. So FAB, you put the unit vector, which is a minus, come on, right, a minus point 429, I minus 0.857 J, right, plus 0. Oh, we left out something here. No? Oh, they haven't left out anything. 0.826K. All right, so that's you write that now. You can expand the bracket back. And what are you getting from the bracket here? You're gonna get F 0. Let's write the negative first. Minus 429 F AB I minus 0.857 F A B J plus 0.286 times the force AB, and this is K. We have all the minuses, so this is minus. Right, we want to make sure that we don't mix it up with equal sign away from it. All right, the last one, so it is F AD. AD now is equals to the scalar value of AD times the unit vector of AD. All right, so what do you get from this one? All right, so this one is pretty straightforward. So it is F AD, and you put the unit vector 0 I plus 0 6 J plus 0.8 K. All right, and you expand that. Let's expand it out here. You will get 0 J, so 0 for that one, plus 0.6 F A D J plus 0.8 F A D for the K. All right. So those are what you get there. So you have 3 force now, and you're able now to form your expression. All right. All right. Now you look for all the quantities that are in your X. Let's look for it. Where is it now? All the quantities that are in your X, let's look for them. So let's look
So you do the
we have
sharing of the
done
unit vector.
Yes, sir.
You never put
for Z, we don't put in the Z one.
Wait,
We
sir.
don't put in the Z.
For we
We
didn't
don't
finish
include the
B.
Z yet. So we need to write one more equation. Well, says F which one was it again? It was the one going in the Z. So it would have been the vector so it's the unit vector going in the Z would have been what now? Is the Z direction? Come on, writer. I can't see this writer. Let me put a different one. So the Z, you remember the one for the Z would have been the minus 20. So it would have been 0 I plus 0 J minus 20. That's what the force was, minus 20, right? So the problem was minus 20. Minus 20K. Right. Right. So that is the force in the Z direction. So
but didn't you write it in the unit vector over here?
No, we never do it.
We never do it. We never do it. So in the one on the slide, we would have said that it is the unit vector of AB unit of C between C and D, right? So it's UCD. That's the form, that's how we write it. So it would have been unit vector of what's the one at the bottom again? B C CD. So it would be, we wrote it C CD, right? So it's the first time that is what would have been this one. Right? But it's all right. You don't have to write that. Let's just get, so now we're going to look for the sum of the forces in the X equal to 0, and we're going to sum all of the forces in the Y equals 0, and the sum of the forces in the Z equals 0. So that is what we're doing. So we're gonna pick them out now. So you go back in and you look for all the X component to do the X. And let's identify them. So see one here. And then see the next one here. And see the next one right here. So this one would have been, let's write it, 0, 2, 8, 6, F, A, C. So you get an AC in that. Plus, no, it's minus. Let's see if we get that right. So we have a minus. Where is it again? What's this value? 0.429 FAB, right? And that equal to 0 because, right, the Z is 0. So the Z is 0, so you don't have to put that in. You see that, right? Everybody see those? So look for the blue line. We identify the blue line for all three expressions. Let me use a different color now for the Y. So the Y would have been this one. For that one, this one, and this. So this is Y. So let's write them. So it is minus 0.857 FAC. Then what about AB now? Would have been minus 0.857 FAB. And then the last one would have been plus 0.6 FAD equal to 0. I want a different color now. I want something that is still bright. I think I have that one already. Let's use black. All right, the last one I'm going to use black. Is that the best color? Let me try the orange. So we'll go with this one. This one. I will go with this one. I will have to include this too. Alright, so this one, so it is going to be 0.4285 FAC. Then the second one would be plus 0.286 FAB. And then the next one would have been plus 0.8 FAD. And the last one would have been minus 20 equals 0. All right, so let's check those that we have derived to see if those are correct. All right, let's check them. See everything that we have written so far. All right, yeah. Yeah, okay. 2 minus 2 minus, yeah. And the last one would have been what now? They're supposed to be all positive. 0.42 for AC and AB. All right, good. So those are the equations. So once you write those now, you would go about solving there. Anybody have an idea how you would solve this expression? These expressions. So these are three simultaneous equations. I need ideas of how you is gonna solve these. What to do? So now you have equation 1. Let me get a black writer now for the contrast. So you have equation 1.
So like we have equation 1.
Equation 3.
You can equate FAC.
So which one you want? Which one? Yes, go ahead.
So you can equate FAC and FAB, then divide
Which one you want to transpose for from the first equation?
FAC.
FAC. All right. So we're going to rewrite it and we transpose. By the way, the person who came in late, could you kindly drop your name in the chat, please, as a point of register that you are here? Or the person who came in late. All right. So now you do that. We're going to transpose. So we're going to make FAC the subject. So in doing so, you're going to take this minus 0.249 on the other side, so it becomes positive 429 FAB. and you divide by what the coefficient of FAC, which is 0.286. And so that must give you what now? What is that value, please? And people, I want it to be working with me. Thank you. That is what? Minus 286. So you get 1.5 FAB. All right. This is now equation 4. What's the next step here, so now? I'm waiting. What's the next step, guys?
Oh, so you plug that into equation.
So what you do, you're going to substitute this value into both equation 2 and equation 3 to get 2 equations. So you're going to substitute equation 4 in equation 2 and 3 separately, and then you will get a simultaneous expression that you're going to solve. So let us take this over with us, and we'll go to a brand new page. Time is now for a brand new page. All right. So let's get to a brand new page. Okay. All right, good. So there we have a brand new page now, and we clearly see what is it that we have with us, and then we're gonna work from this. I don't want it too big, so I also want to remember the values that we had before. All right, can you all see that? All right, so now let us proceed to work. All right, so for the next step now, we're going to substitute. Let me make this right a little bit bolder. You can see it. So we're going to substitute equation 4 now in equation 2. So from that, so we're going to substitute equation 4 in equation 2. That looks a little bit too heavy. All right, let's drop that a little bit. It look a little neater. So it is minus 0.857. FAC now is going to put a bracket beside it. And anywhere you see FAC, you're going to put 1.5 FAB. Close bracket. Because that's the first one here we're working with. The one in red. Right? So the one in red, put it to a back red. 0.857 FAB is left there. Plus 0.6 FAD equals to 0. All right, so that is what. And if you were to simplify that, can somebody work that out for me, please? So it's 1.5 times 0.857. How much you get with that? You get a minus 1.285, or you can call that 6. I don't have too early, but call that 6. And that is FAB. So, and this is minus 0.857 FAB. So simply, so you're going to sum those quantity. All right, FAD. All right, when you sum that, so that's minus and minus. You had another, you had the other minus 0.857 to that. So you're gonna end up with, so this gives you 2.1425 FAB. The guys did it in class last night, but I think someone on the line ran off a little bit early. So they didn't get the correct answer. They were close. All right, so that now, So that is the first one. So you have one equation already. The next one you're going to substitute equation 4 in equation 3 now. So you're going to do it now. So you're going to substitute, let's take a different color. Substitute equation 4 in equation, we did 3 in equation 3. All right, so let's do this one now. So anywhere you see equation 3, what is equation 3 again? See it here, let me write it down first. So it is, I'll write it down first this time. It's a little bit long, 0.42. I'm gonna call this 9, make it a little bit easier to manipulate. Plus 0.286 FAB plus 0.8 FAD equals 0. All right. Now that you have done that, you're going to put in, so you're going to substitute in this value here, FAC. Anywhere FAC is, you're going to put 1.5 FAB. Can't go wrong. All right, so let's proceed. So right here we have 0.429, open bracket, put 1.5 FAB. This don't look like a B. All right, and that's close bracket, plus 0.286 FAB, plus 0.8 FAD equals 0. All right, so now let's expand this, please. When you expand that now, what you get? 0.429. You have to work with me, guys. I'm not hearing you. Hello? You guys gone silent on me, man. What's going on? So you go 0.4. You get 6.4, sorry.
0.6435 or
3.5.
0.644.
4, yeah. Let's call that 4. And this is, let me write that. It's a little bit muddled. Let's rewrite that. So it is 0.644. And this is FAB, all right, plus 0.286 FAB plus 0.8 FAD equal to 0. All right. And when you simplify that now, add the ABs them together, you get 0.6. Did I write that correctly? Did I write that the first one correctly, guys? Did I mess it up? 0.429. Did I write the first one correct? Confirm, please. It's 44. Okay, I'll just confirm it. It's 0.644 plus 0.286. And you sum those, you get in here now. I'm gonna write over here. So this will give you 0.93 FAB plus 0.8 FAD equals 0. So right here now we have two equations that we're going to solve. Two simultaneous equations. So you're going to solve these simultaneous equations. Can anybody tell me how you're going to solve these? We'll move up a little bit. So the equations that need solving are these. All right, so let's write them again. It's 2.143, yeah, FAB plus 0.6 FAD equals 0. And I need, can somebody solve this quickly for me, please? All right. And you tell me the answers quickly, please. Plus 0 point, and tell me what you're doing. You're going to use substitution or elimination. Did we Was the 20 included in our equation? Where's the 20? Did I carry down the 20?
No.
Oh my good Lord. That means that the 20.
Sir,
So hold on. So
so let's equate it to 20, sir.
the 20 in equation 4. Where's the 20? Where's the 20? Nobody catch me up. In
So
equation
let's
3.
equate it to
Let's put
20.
it to 20. Yes. Let me just see. Listen me, guys. I like you to be working with me.
So I did forget it too much.
Right. So the thing is, you're gonna have to just you have to just concentrate. What is what? Blue. So it's 20, 20, 20. So this is 20. All right. So so this is 20. All right. Okay. All right. How are you going to solve that now? It's easy to forget that 20, you know. Easy, easy. All right. So how are you going to solve that now? Anybody have any suggestion?
There's simultaneous equation.
Yeah, man, just solve it. Tell me the solution for this. How are you gonna solve these? You should be just spitting out the answer immediately. What are you going to do? Elimination, or are you going to do substitution?
Elimination.
All right. So you're going to multiply the first one by what? 8, and last one by 6. That one will work for you?
Yes, sir.
All
Yes,
right.
sir.
So what you get here now?
Wow.
So it's 2.143 times 8. You get what here now? You get 17.144 FAB
So 8.8.
plus 4.8 FAD equals 0. And the next one is the same thing, 6 times.
Sir, 8 or 0.8?
0.8,
8 or 0.8.
0.8, 0.8.
So that means it would have been 1.7144.
1 point. No, what are you talking
So,
about? What?
so
Which one? What? Come again.
So you say multiply the top one by 8 and the
8
bottom one by
and
6.
6. Yes. Yes. That's what I said. Times 6. So it will be what? 5 point something. 5.58 FAB plus 4.8 FAD. These are AD equals to time 20. That is how much time 20 again? That is 120. All right, 120. Let's fix that. Let's clean that up. All right. So there you go now. You subtract that one, get 0. This one give you minus 120. Subtract this one, you get what? Minus check those values for me. Do I have all the negative and positive in?
For the equation 2, but
Is there we leave out any
the
signs?
negative,
Which one is
the
supposed to be
negative on the
minus?
top one, the negative
I'm looking at I left
2.143.
out a minus sign somewhere about the place.
Yeah, negative 2.143.
Okay, because I'm looking. Yeah, this is minus. All right, thank you. Yeah, we have to be careful. Yeah, so this one is actually supposed to be minus. Yeah. Yeah, that is minus. Good. Yeah, so that is where we would have So this one is going to be minus what now? This is minus 20 something, 23, 17, minus 17.144 minus 5.58. So you're getting, this is not correct. 17. You're getting 22.7 minus 22.724 F A B. So you transpose of that, F A B is equal to minus 120. So minus cancel minus, if you want to do it that way, 22.724. All right, I know what you get with that. No. So you get 5.28. What was it again? Pounds? Yeah. 5.28 pounds. Any decimal behind? 5.21 pounds. Yeah, it's approximately correct. All right. And then the next one. All right. So from this now, what would you do now? You go and you know what is FAC. So FAC, recall. So here now, you recall that you have FAC, which is equals 1.5 FAB. And it's just a matter of substituting. So it will be 1.5, open bracket, 5.281. And you multiply that by 1.5, and you will get 7.92 right, pounds. And the last one, how do you get the last value? Which other one we need to find? So we have AC, we have AB, but we don't have AD. Which one of them have AD now? The last well, you can choose any one of the expression. Any one of them, the easiest one for you, you can choose to put it in the very last expression. Or so anyone between equation 2 or equation 3 will give you that value. So it's your choice. I'm just gonna write anyone that I see AD in. So you can just write, even from these, you see from the simple version here, you can use one of those two. So we're gonna use one of the simplified version. Let's use the simplified version and we'll pick up the answer. Easy. We don't have to use it, we don't have to use that. We can use these. So you can use these two. Can use any one of these. So let's use the last one. So you have 0.93 FAB plus 0.8. You can use any one of these. Equals to 20. So it would have been, so you put AB in it, so it would be 0.93 F. AB now is, what is AB value? AB is 5.281 plus 0.8 FAD equals 20. And you know, sometimes solving that. So that is going to give you what now? 0.8 FAD equals 20 minus, when you multiply that, how much you get? 0.93 times 5.281, and you get what? So it come over as 4.911, and that is equals to 15.089. So FAD divided by 0.8. And you're getting what now with that? 18.86 pounds. So right there you have solved for what are the answers that you're looking for. So you got this one, right, for AD, tension in AD. You get this one also, AC, right? So AC is actually this down here, right? And you have AB above. So you have all three all three of them, right? All right. Any question there? It's just manipulating. The last part already was solving simultaneous equations. So when you went to high school and they're teaching you about process of elimination and substitution, and you could also use matrices to do this. Use a determinant and solve it. But that's for you if you want to experiment as mathematicians. All right, what's the next part of the question now? How much time we have left? We have about 24 minutes left. There's another part to the question. What is it now? Let's go back to the question. Let's go back. So we have solved for, we are at part C. It says express the tension in rope AB as Cartesian vector pointing away from A. What are they saying to you now? What are they asking for you, from you? Who understand what is it being asked? Huh? What is it that they want? No. Still asking more questions. They're not satisfied. They want more solution from us. So we're gonna get a new page. We're gonna have to pick up some of those. We have them already, so we're just going to utilize them. Have everybody read the question and following? Hello? Do you
I don't
understand what?
understand what you're asking.
Pardon me? I'm
I don't
saying
understand what you're asking.
you don't understand what I'm asking. I'm asking you.
What the question is asking.
Oh, you don't understand what the question is asking? That's what you're saying?
Yes, sir.
All right. Wow. What did I do a while ago? What did I do a while ago? I was trying to reposition it and this thing just come all over. You over here. Okay. All right. What the question is asking you? I think I finished manipulating now. All right. Yep. All right. All right. The question is asking you. Oh Lord, it's a little bit fine here. And even me can see it. Could select a section or rectangle. All right. Let's get it out. All right. Question is saying to you. Let me see if we can be clear on what this question is asking. It says here.
I think I get it. The force along each component.
Let's go. It's question D, It says express the tension in card AB as a Cartesian vector pointing away from so they're focusing on AB. So you the force going into AB, don't. So you know what? So let me get a different color item. So F AB is equals to F, the scalar value of AB, times its unit vector of AB. Do you agree with that? And
Yes,
it's
sir.
going. So it's going from, so it's AB that asks us about. So it's AB pointing away from A. So it's this way. See there? It's going in that direction, if you can see what I've marked a while ago. So all you need to do is get the scalar value of AB and multiply it by the unit vector. Isn't that what you need to find? Now, so they say in Cartesian form, but don't we just find AB, what was AB value? AB value was 5.283, right? Or we found it as 5.28. to
Yes, sir.
be perfect. So it's 5.28. What was the unit vector now of AB? We found the unit vector to be, where is it? Way up there.
Minus
Where?
0.429.
So see him right here. Let me just see it right here. It was -2. See him right here? So that is what we want. So we're going to look for that. So that is unit vector that we need. And we're going to multiply it by that quantity. Right?
Sorry, could you just use like when it first the question C?
Pardon me?
And yet the same, the FAC equal FAC thing. Or FAB. Yeah, the
No, that
FAB.
is
No, wait. No, the FAB. So like the 5.28 times the Cartesian.
No, it's time the unit
Oh no,
vector.
yeah, the unit vector.
Yeah, that's
And
what
then
we're
you
doing.
get the I, you get the J, and you get the K.
Then that we do, man. Yes. So the unit vector. All right. So we had found the unit vector to be UAB, which we just highlighted was. Let me write it down and remind you what it was. It was minus 0.429 I, and it was minus 0.85. What was the other part? 7 J. Oh, this is meant to be 7, guys. Yeah, 7. And then the other part was plus 0.286 K. That is the unit vector. So that is what we need to multiply it by. So it is minus 0.429 I 857 J plus 0.286 K. Right. And when you expand that, now what you get, guys? And that is your answer, whatever you're going to get. So it is minus 2.264 I, of course. What's the next quantity? You get what? Minus 4.5
4.525.
to 5
525.
or 2.8 or whatever you get. What do you get? 2.24 what? What that give you?
25.
2.5, you sure?
4.525.
Okay. All right. 5 you said. All right. So you could have, okay, J. And then the next one, it would have been plus what? 1.5. What? No. What you get? 1.5 what? How much?
1.51. 1.
1? Sure. Okay. All right.
Yes, 1, sir.
We run off some early bit. Sometimes you run off a little early bit, you don't get the answer as proper. So
It would have just be 1-0 then, sir.
yeah. So that is the amount of pounds. So yeah. So that's what they're asking for. All right.
Sir, hold on. Is it negative 5.28?
Negative what? 1.5
5.28.
Positive. Remember the unit vector was positive, so it couldn't become negative. Remember the unit vector that the Z quantity was positive. You recall? You see it up top?
I don't remember.
Yeah, man. See it we have, but we see to have it up top here now.
Oh no, as in from the previous question.
What? If what was from negative from the previous question?
The
We had
FAB.
found it going the other way at one stage, They had asked us, they had asked us, the position vectors going the other way in the first instant. But then we had to reverse the order by multiplying through by -1. So we reverse the
Yes,
position
sir. I think you might
vector.
have FAB.
Hold on, let me go back down
Yeah, I
here.
think you might ask FAB value what would it calculate. That's kind of
It's positive. Yeah. 5.283. So remember 5.283 is a scalar value of the force. When we say scalar value, we mean the numerical value. So sometimes I don't want to use scalar value because it may confuse students. How can I refer to a vector as scalar? What we really mean is just the number, the actual number of it. the numerical value of the force.
All right, I see.
You got me?
Yep.
So if I mention scalar, don't be mixed up. How we talking about vector quantity, we talking about scalar. It means it's just the numerical value. So sometimes we do refer to in question about the scalar value. I think in the notes you saw something about scalar value. Students may be
When I call
confused
it
that there.
scalar.
Huh?
So when I call it scalar, because when I know says the magnitude of the vector.
Ah, yeah. So again, no, I kind of started to reform myself from using scalar that much and see that the magnitude because students sometimes confuse with that term. All right, so the next one, what they say they want there, express the tension in rope AC in terms of magnitude and coordinated angles pointing away from A. So we need to find the Cartesian of AC now. So the Cartesian of AC, so AC first of all, so it's F AC is equal to the this is so we have to call it the scalar value of the force here. Right, this is a kind of appropriate. The scalar value of the force or the magnitude of the force times its unit vector AC again. And here now, what was the scalar value? It was 7.9 something 7.9
7.92.
2. All right, and then we multiply it by its unit vector. What was its unit vector? Let's look and identify its unit vector. It was which one we're doing again? It's AC. See it up top here.
Yes, sir.
I can highlight it. See right here. One quantity is minus this guy right here. So that is what I need to write down down there. Actually, I could just take a little bit of picture of him and carry him down there. I hope it's not big. It might get very big down here. Where is it? Very big. Oh, come on. All right. So this is it. So right here. Let me get a different color. Go again. So it is right here times this. So when you expand that now, what do you get? Expand that and give me and tell me what you get, guys. When you expand that, what do you get? So what's the first one? Well, this is
2.265.
2.265. And that's a I. The next one is minus.
Next one is minus 6.8. 6.787.
6.7. Oh, let me clean that up. That don't look good at all. All right. So this is so it's 0 point or 6.
6.787.
We could actually call it 6.79. All right, 8.87. I'll put the 7. Yeah, it won't kill. All right. And then the last one is what now? A plus. So it is 0.4285 times 7.92. What you get for that one?
3.39.
3.339 K. All right, so that is your vector representation in Cartesian of the force. So now we have moved the force from what you call the magnitude to a vector representation, and the vector representation is in Cartesian vector form. Is that clear?
Cartesian vector. Yes.
It's in Cartesian vector form, but they also want something else from us. So we have found, so let's say express it in AC in terms of magnitude and Cartesian and coordinates angle pointing away. So we need to find the coordinate angles. Can someone tell me how do we find the coordinate angles? No. So and that is our AC.
So for the x angle, so then use cos alpha equal the x component over the magnitude.
So right here we need to find the modulus of this. Do we have the modulus? We need to find the modulus of the vector.
Definitely.
So
the modulus is
so f AC modulus is going to be equals to 2.265 square plus minus 6.78. This is 6.787 square plus 3.39 square, and you take the root. Can somebody give me the answer for that, please, and make sure you calculate it right?
so I got 7.9192.
7 point what?
92.
7.992. All right, because that was our vector before. That was our answer. But, well, not necessarily answer, but it was kind of
close.
Yeah.
Yeah.
7.91. Yeah, we deviate a little bit. You're not sure, do them something correct. I want to deviate the answer so far.
So it's not 992, it's 91.
912.
Yes, sir.
7.912. I want to get it so far gone because we already know the answer. The scalar value is 7.92. So you're supposed to get back 7.92, man.
7.92.
Yeah, 7.992. Sorry, 7.917.
Yeah,
so you can call it
so you actually get back the same value. Because we know the modulus. So therefore, if you take this and divide this original vector, what are you gonna get for your the unit vector of it? So the unit vector of AC, we already know it. See it here? Can rewrite it. See it here? We don't even have to calculate it. See it here? And this is the force. See there? So we actually know what the unit vector is. So we not even calculate, we just write it back down. Right, so once you have the unit vector, you will just apply the cos alpha alpha is equals 0.287, right? Cos beta is equals minus 0.857. Let me go up with a little bit. And then the gamma, same thing. Gamma is equals to last one, 0.4285. Can you find those angles for me, please? So alpha, beta, and gamma. Give me those answers, please.
Alpha, sir, 73.3.
73.3. And beta?
Beta. 0.8.
Minus 31.
Come again. It's minus, It was a minus value.
So I think 149, yeah.
148.9.
So it's 149.
Yeah.
Yeah. And then the gamma,
64.6.
64.6. All right, good. So those are the angles that they wanted for you. So those are the coordinated angles pointing away from A. So what they're actually saying that this is the angle in reference to the x-axis. This is your alpha 73.3. In reference to the y for that force, wherever that force is, where AC is. So AC is here. So if you're referring it back to the origin, that is where the angle that wherever that line is inclining. So it is 149 inclining to that axis. And likewise gamma from origin to that point, it is 64.4. So that is a coordinated angles. So you notice how many questions have been asked about coordinating angles. All right, the next part of the question, it says F now, and we see we probably have a minute. Find the angle between the rope AB and AC. How do you find the angle between the rope AB and AC? What principle are you gonna apply here?
Dot product, sir.
Thank you. That product. So we're going to say that the AB, that the vector of A Cartesian and the vector of AC, that when you dot them equal to the modulus of A, and we have all of those, and we think we have the modulus of AC, so we can look for them and quickly write it. Right. So therefore, we can find the angle between these. So the coordinate of AB, what was it? We just wrote it up here. So you see AB there. Let me put them. Let me just scrap them and put them beside each other. Not even bother to write them. So this one here, yeah. So whether or not you want to use a force or you want to use you can use a force, you can use anything you want to use. Let's put them. You can use the position vector or you can use a force. It doesn't matter. All right. So if you use a force, you have to use a force all the way through. All right. And what is AC1? AC was this value right here. And you can say this one right here times, yeah, times this other one here. Let us put in them in because we have them already. So see it here, two of them right here. So those are two. So you have this one here. Actually these things shouldn't come down. Those, you have those multiplying each other equals to the modulus of them. We have the modulus of the forces already. The modulus of AB, we know it is 5.28, right? And so it is, let's write it down, 5.28. And we have the model of AC, which we know already it is 7.92, right? Because we know those times the cost of the angle between those. Once you solve this, so you would say now, you would multiply minus 2.264 times 2.265, right? So you're gonna get a minus quantity there because one is plus, one is minus, plus minus 4.525 times minus, so you're gonna get a plus quantity here, 687, right? Plus, so you're gonna get a plus quantity there. Then the next one would be going to be 1.51 times 3.39 equals to, when you multiply the forces, what you get? So it's 5.28 times 7.92. You're gonna get what? 41. And you need to be working out the other part. 41.8 176 times the cos. So what you work out, when you work out these, what you get? So it is minus 2.264 times 2.2265. You get a minus quantity, which gives you minus 5.128 plus, what's the middle one now? But if we work out that yet, minus 4.525 times minus 6.787.
28.86.
How much you get for that? 30?
28.86. 28, sir.
You get 30 something here, sir, for this one?
28, sir.
28?
28.86.
Come again, check that again.
So if we get 30.7.
30 point. Oh, come on, that now have my calculator. Yeah, you see, you made a little error, pops. All right. And then the next one would be what? 1.1 times 3.33. Hold on, I have too much 3 there. 9. So you get 5.1. 5.119 equals to the 41. 8 177 and cos theta. So when you sum all of that now, we're getting the 30.711 minus 5.128 point what? 7019 equals to
30.70.
Yeah. Times the cos. So you transpose of the cos, and what you get now? You transpose of cos theta is gonna be equals to 30.7019 upon 41.8176. And what you do, and then you get that and do the cos inverse. 41.8176.
42.
So you get 0.734, and the cos inverse of this. What you get? What is the angle you get there?
42.78.
Ah, beautiful. Yeah. So it's the angle actually is 42.76. Right. So that's what you get for the angle, right? So whether or not you use the position vector along the line or you use a force, and I deliberately use a force so as to show you that whether or not you use a force or you use a position vector, because you could have gone up here, look for these position vector right up here and use them, right? And they will give you the same answer, right? So actually, it's really what I've used there is not the position vector, is actually the force, which is, if I was to write that properly, it would be written like this. Let me see. It would be FA B. It was AB, right? The vector of representation of that time FA C vector representation equal to the modulus of FAB, modulus of FAC, right? Because of the angle. So it's the same thing, right? So whether or not you use the position vector of the line, of the length of the line, or you use the force, is the same thing, because two things they have in common. They have the unit vector is the same, whether it's the force or the line. Do you get that? The commonality between the position vector and the line, whether the force or you use the position vector, is a unit vector. It's that's what they have in common. The unit vector is common to whether the force or the position points. Everybody understand that? Who don't understand the statement? Anybody don't understand the statement? All right, so I take it that everybody is clear. So whether or not you use the position vector or the force along the line, the unit vector is the commonality between them, and you get the very same result. All right, so the next part of the question, which our time has gone, it says here, how many pounds of tension in rope AG is projected along AC? Who know how to do the projection of forces? How do you get the projection of, and that is what now? That is G. How do you get the projection? It's very, 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 very important. The projection of the force. So we're asking for the projection of the, let's read it back again. It says G, how many pounds of the tension in rope AB is projected along rope AC? So this is now G. I didn't do any labeling before. I can go up and label them. This is G. This is F, A, B, projected onto AC, right? So this is what is happening here. So it is F, A, B, dot. So it's always going to be the force that is projected onto. We use the unit vector. So it's the force. The force says AB is projected onto AC. So you use the force of AB and you use the unit vector of AC. So it's a unit vector now of AC that is, so the line that it is projected on, you use the unit vector, which is UAC, right? So you know
So
the
just
force.
multiply the force by the unit vector of what they're
Yes,
projecting on.
yes. So what was AC, force AC again? See, AB, sorry. AB was this quantity here. See, all right.
5.28.
So it was, no, remember, is a Cartesian form one, you know, minus 2.264
Oh.
I minus 4.5 25 plus 1 this is 1.51, right, K, right, times what was the unit vector again along AC? The unit vector along AC is the one that we need to look for. What is the unit vector again? We're just trying to remember the unit vector. The unit vector for AC. See it over here? See it right here, so? Remember this one right here? That is unit vector of AC. But the unit vector is, as I say, it's common whether or not it is force or it is position. That's a common thing about them. So you don't have to worry. That is what is common, and it's too big. All right, so you put it right here, and then now what you do, you're going to dot them, and you dot them, you'll be getting minus 2.264. Oh, I've been trying to compare them. 0.28 5. So those two together. So those are the I. And then the J would have been minus 4.525. Times what now? Times minus 0.857. So you're going to get a plus from that. And then the next one would be 1.51 times 0.4285. All right. What do you work out this sum, Tell me and get that value for me, please. I think your answer, I can tell you what your answer should be. The answer should be 3.88 pounds. let's work them out, see what they are. So it is minus 2.264 times 0.285. So you get in here, what is it? You get a value here. This is a what? A minus value, right? Minus.
Yes, sir.
Very small value. 6.
Answer yourself again.
Yes, that's it. No, the first one. The eyes. Right? And then the next one you get a plus value. What is this plus value here now? It is minus 4.525 times what now? Minus 0.857.
3.87, sir.
So you get 3 point,
3.88.
come on, writing down. 3.877 plus the last one. Supposed to be a small figure. Times 0.4285. So you get 0.64
Zero.
70. Yeah. So your answer is essentially all of that add together minus 0.465 plus 3.877. Right, so you end up getting
3.9.
3.8 7 pounds. All right. So essentially that is the answer. And the last part of it now, the last question, I know the time gone a little bit. It says how many pounds of the tension in the rope AB is perpendicular to the rope AC. Now, you remember, all right, so you have two ropes, one projected on the other. Where is it again? Let me look at the diagram. So you have AB projected onto AC, right? Once it's talking about perpendicular, you already have it parallel. So the parallel value you have is, where are we? Where am I going so far? Where am I? How did I end up back on this page? How come my page end up in the middle? Oh, I end up in the middle. All right. So all we have here, right? You need that the pages need to be reorientated. All right. So the H is if FAB is projected to the perpendicular of AC, right? It means therefore that what we're saying FAB from the text is equal to the sine of the angle, the sine of it. So right? So we had found them. We know the force for AB, then we have the angle between AB and AC. Remember we have the angle between them? The angle between them was what again? You remember it was 42.276, right? Yeah. So right. So remember, the angle that we are finding is this angle. The angle that 42 is this angle right here. The angle between them. So we found the parallel to it. So one, remember, how can I draw this now? Show you. So we had the two of them. So one was AB and AC. We found the angle and we found the parallel to it. After you find the parallel to you can find the one that, so we projected AB onto AC and we did the parallel. And the parallel show that this value appears it. The 90 degree to hit now is going to be the sine of the same angle to hit. Right? So it is going to be the same. AB was what was the value of AB again? 5 point something? 5.8. 8. No? What was it? That value again?
5.28. 28.
5.28. So it's the sine of that same angle here between them, which is, so this is angle is a 42 point, what was that value again? 42.76 something there, yeah. So that is it. So it is this angle here, 42.76. So if I ask you for the projection of one line onto the other, you know that it is just going to be the force that you look for the unit vector in. So so you'd have to look for the unit vector in this line. That's how we did in AC and the parallel. So see, that's how we got the first one up here. This one, right? So this is how we got that one. And all you're going to do to get it 90 degree, so you get this projected onto AC 90 degree. It is just it's the sine. It's the sine of it, right? So it's like this. It's like the two of them in a plane. One is projected on the other, right? So let's say that this was AB, and then AC. Let's say this is AC, argument's sake, right? So to get it parallel to this, right, you have to look for the unit vector of AC here. So the angle here would have been 42, and so it's something like this. So this is parallel, this is perpendicular. It's the same kind of thinking. All right. So that is the same principle. All right. So, and this one will give you what now? 3.5? Body point 3.5? 3.58?
Yes, sir.
Pounds. All right. And that is it. So that is projection, perpendicular. So that is known as the perpendicular projection and the parallel projection. So the parallel one, it is this force here. You use the Cartesian form of it, right? If you didn't use the Cartesian form of it, how could you also find it? It would have been the same. You could also use this formula here. F, let's write another formula for you for the parallel. And you need to know this. F AB parallel to AC is also equal to F AB cos of the angle between them. So it's this angle here. All right, so that angle here should give you the same thing. Check that for me. So the scalar value of it was what? 5.28, you said? That's what you said it was again? 5.28. 28 times the cost of it. So cost of 42.76. That should give you the same answer. Yeah. So you get the same answer with that one. So this gives you a 3.876, just the same. See, but then I use a cos, I use a unit vector. Because the unit vector and the cos are giving you the same thing. So those are two expression for projection of an angle. You follow that? So it's two expression. You get two there. And if I ask you for the 90 degree to it, you know it's just the sine of the same angle. Because it's like a right angle triangle right there. Their orientation. So one angle projected to the other, you get it parallel or you get it perpendicular. Once you use the formula, you're gonna get it right. All right. All right, guys. So that is it. I trust everybody registered and you all understood what is happening.
Sure, more than yesterday.
More than yesterday. It's understandable because that was, let me pause. So that was the lecture. So you're not gonna necessarily